Hi. All right. So today we're going to be looking at how to do unit conversion problems. And these are some of the units actually you're going to be looking at in your classes. Don't worry about too much if you don't know them immediately. You don't have to memorize, 1 liter. Well, you'll eventually memorize it because by the time you're done with your chemistry course or your math course or whatever you're doing this in, you're going to be so sick of looking at your conversion tables that you're going to know this by hand, a lot of them, like how to convert grams into kilograms, kilograms to tons, gallons into how many quarts that is, how many quarters, also pints into quarters as well. So you're gonna be, very familiar with this. So the first problem we're gonna be doing, let me go ahead and erase this board. So the first problem we're going to be looking at here is how to convert 3 miles into, feet. And this is a very, very basic problem. All you're gonna need to do is that you're gonna need to know whatever your conversion factor is. But the first thing we're gonna do is that you're gonna need to know, okay, so the first thing you do is you put your, whatever you're given or your starting position or your starting unit is over here. So here we have 3 miles. Sorry about the noise if you guys can hear that. So, and you're gonna wanna put this over 1 because these are fractions. We're gonna have to multiply fractions. And when you multiply fractions, it's usually good, especially when you're doing unit conversion to always have everything in fractions, right? So 3 miles, and you're gonna convert this and you multiply by your conversion factor. And if you guys remember from the middle of the video, if you guys wrote that down, it turns out that 1, right? So 1 mile is equal to 5,280 feet, right? And this is pretty much all you need. You're almost done here, pretty much. So you're converting 1 mile into feet. This is your conversion factor. This is kind of what brings you, what connects, what chains, the miles into feet. So once you're done here, you should have, once you're multiplying, you'll be multiplying 3 times 5,280 feet. So you will cross out your miles, because miles over miles will cancel out, leaving you only with feet. Correct, right? And then now what you're doing is that once you multiply this, you will get 15,840 feet. And that is if you were to convert 3 miles, right? A very long stretch of distance into just tiny slices of feet, which is, feet is a very small distance compared to a mile. It'll take you a lot of feet to cover that long distance. So that was the first problem. Now we're gonna look at now I want to show you guys how to do a multi conversion problem. So one that takes more than just one step. This is what you call a multi-step process. It might say that in the books. So now we're gonna be converting. So we're gonna deal with, that was length. So now I want to do something with mass. So let's say we have 5,000 grams, right? And we want to convert that into what is tons, actually. So how many tons? 5,000 grams is how many tons? What is that if you're talking about tons? Well, again, just like the last problem, we want to first start with our given, which is grams in this case, and we want to put that over 1. Sometimes this won't be always over 1, like if you have kilometers per hour, it will be kilometers and then over 1 hour, but that's a different problem. It's a different day. That's another topic for a different day. So here you're going to multiply by your conversion factor, but here we don't know what the direct conversion is from 1 gram to ton. So what we can do is that we can go, and I'm gonna write this on the side, we can go from grams to kilograms into tons. And this is what you do when you don't have a direct connection. Like you have to chain these together. You have to chain, grams to kilograms and then into tons. So that way you get, so that way you can, it's kind of like a path. You follow or a chain, if you want to call it that as well. So I know that, okay, if we're not converting from grams to kilograms, well, we're gonna want to put, all right, you have our grams at the bottom, our second at the bottom, and our kilograms at the top, like that. So that way when we multiply, our units cancel out. Your units should always be canceled out. If you have like, you know, doubts about a problem, make sure your units are canceling out, and you're always left at the end with the unit that you actually want, right? So grams into them. So so in 1 kilogram, right, there are how many grams? Well, there are 1,000. That's what a kilo means, if you didn't know that. All right, just in case. And then from there on, you will have, right, so how many kilograms are in a ton? Well, in 1 ton, you have actually 1,000 kilograms, right? And this is pretty much a multiplication. If you see here, okay, well, look, your grams are going to cancel out. Grams cancel out with grams. Kilograms cancel out with kilograms. And then you're only left with your ton here. You're only left with your ton there as your final unit, which is actually 1. So all you got to do there is just multiply, right? And that turns out to be, because I'm such a robot, I know that this equals to 0.005 tons. And that is how many, if you were to express, you know, 5,000 grams into tons, that is how many tons you would have, right? So that is how you do a multi-conversion plan. You have to remember to chain these together, right? Chain what you have. First off, if you have a multi-step, you don't have something there. If you're on conversion factor, you're gonna have to chain conversion together. So that's why I went from grams to kilograms, and then from kilograms to tons. That is how I did it, because I had to chain these together. You know, this here should cancel out. This here should cancel out, leaving you only with your final unit, right? Now, the last problem we're going to be looking at is actually this is actually a problem that some people get confused. I know when I was learning this, I did get confused, and I had it. I think I did bad and I quit because of this, because I did not realize it at first. Is that we're going to have to convert. Now we're going to convert. So it's our last bonus problem for you guys. So we have 35 meters cubed, right? So, and we're gonna convert this into, we don't know how many is that in liters, but I'm like, if you think about this, it might not make a lot of sense at first, but you have to remember 35 meters cubed, it's a unit of space. You have for example, you have a box here, right? You have a box here, strap, and you're saying that this whole box is 35 meters cubed. So if you had, you know, see unit here, meter here, it's a whole box, right? It's a box of space, but you want to express that in liters, right? Because this will let you know if you want to put the same amount of space, if you want to occupy the same amount of space into maybe not another box, maybe it was like a bottle, right? Or a very large tank, right? You need to know how many liters you would need to fill it out, so you could have a big enough tank, right? So now, so this is also going to take, it's going to be a multi-step process as well, but now we're going to deal with, you know, how to deal with this power here. So again, you start off by making your, by writing your start unit, squared. So now meters, this is meter cubed, right? So we know from our conversion factor, we have conversion factor, this is from meters cubed, well, sorry, from meters, right, into centimeters. And we know that from our conversion, we're gonna go from centimeters into actually, into milliliters, and from milliliters we can get to meters. So I know that's a little bit of a marathon there, but what you can do is that when you have just a basic conversion of meters to centimeters, so all you gotta do is just cube the number. So if you want to get from meters to centimeters, but again you have meters cubed, you can do is just write the basic conversion factor, which would be just 1 meter is equal to 100 centimeters. And to get that, sorry, I wrote that wrong. See, that's a mistake right there. This would be wrong right here because I'm not canceling my units. I would have the wrong answer there. So let's fix that really quickly. So this is what you want to do. You want to put for every meter, right here, for every meter you have 100 centimeters. But again, we need meters cubed, not just meters. So what we're gonna do is multiply the whole, take the whole fraction here to the power of 3, right? That's gonna give us power of 3. You know, that's gonna give us meters cubed here, and that's gonna be meters cubed and centimeters cubed as well. I'm gonna delete this, or I'm gonna erase this, and I'm gonna multiply by the next conversion factor. So now we'll be left with here. Now by this point, we'll have gotten rid of the meters cubed, and we'll be just in centimeters cubed. From there on, what we're gonna take is, again, we know that's 1 centimeter cubed is equal to 1 milliliter, sorry. And then, so we have, okay, 1 centimeter cubed is equal to 1 milliliter. And that's how you convert from this meters cubed into liters, right? Something more you refer to, something you can associate better with volume. You can put together liters with volume there. So that's how you translate it. So then you can do this because, again, you are now in centimeters cubed, right? And centimeters cubed translates to 1 milliliter. And then for milliliters, right, we know that 1,000 milliliters, again, putting your unit that you want to convert from on the bottom so that they cancel out, right, into 1 liter, like so. Now from there on, all you have left to do that is just, you know, if you want, cross out your units, so meters, cross out with now meters cubed that you have here. There's centimeters up here that you have here, cross out with this one. Again, this cross out, I know I didn't write it here, but you can imagine this 3 as it being here, you know, after you multiply fraction. Remember this exponent, if it's you have to apply it to everything inside. It applies to everything inside. So then you have, you know, milliliters cancel out with the milliliters, and you're left with only liters up here. So after you do that computation, you have 35 liters, and now you multiply by 100, so that's 35,000 by 1,000 more. Or sorry, and now we're dividing by 1,000, so we will only have about 35,000 liters there. So we need a tank that measures. So this is why this is important, because if we had say we have this big cube that is, you know, 35 meters, that is 35 meters cubed in volume, right? And but we didn't want like a huge box, right? We wanted like an aquatic tank, I guess you could say. We would use this conversion to see, okay, we need a tank that can hold this many liters, right? So instead of we don't want a box, we want a tank. So we need a tank that holds this many liters here. And that is how you do unit conversions, right? Later.